Hi, this is Algebra 2, lesson 67, and we're going to talk about radical denominators. We're starting on page 283. When a pair of two-part expressions are the same in all respects except that the sign in the middle are opposites, we say that each expression is the conjugate of the other one. So negative 3 plus the square root of 3 is the conjugate of negative 4. Negative 4 minus the square root of 3. Negative 4 minus the square root of 3 is the conjugate of negative 4 plus the square root of 3. Negative 2 plus bx is the conjugate of negative 2 minus bx. A plus b is the conjugate of a minus b. Okay? If you multiply conjugates, the results are always the difference of two squares. So let's do this A. This is negative 4 plus the square root of 3 times negative 4 minus the square root of 3. And we're going to multiply them together. Negative 3 times the negative square root of 3 times the positive square root of 3 is going to equal minus the square root of 3 squared, negative 4, and then the negative the square root of 3 times negative 4 is positive 4 times the square root of 3. Negative 4 times the square root of 3 is negative 4 times the square root of 3. And negative 4 times negative 4 is positive 16. Add those together. This is 9 minus positive 4 times the square root of 3 minus 4 times the square root of 3. That cancels out. And this is 16 minus 9. No, it's not. It's 16 minus 3. Because this is the square root of 3 squared. Sorry. So this is actually the square root of 3 squared. So this is a square and this is a square. So it's the difference of two squares. Duh. Okay, let's try this one. Okay, so we're going to multiply these guys together, and we've got negative b squared minus ab, positive ab, and a squared. So we have minus b squared. These cancel out, and we end up with a squared minus b squared. Okay? So it's the difference of two squares. In A, we saw that when you multiply the conjugate of expressions that contain square root radicals, we end up with whole numbers. We can use this to simplify expressions like 1 over minus the square root of 4 plus the square root of 3. We say that an expression containing square root radicals is in simplified form when no radicand has a perfect square factor and when no radicals are in the denominator. So we've got two things. We have to simplify any radicands. Remember, that's the number underneath the radical sign, so that there aren't any prime numbers that can be pulled out of it that were squares. And there can't be any radicals in the denominator. So let's try simplifying this, except that's not what I'm simplifying. Let's try simplifying this. That makes a whole lot more sense. Okay, so we're going to multiply the top and the bottom by the conjugate of the denominator. So that'll be negative 4 minus the square root of negative 3 over negative 4 minus the square root of 3. These two multiplied are going to end up with 16 minus 3, right? There's 16, there's 3, and we know that the middle parts are going to cancel. So 16 minus 3, and the top will be negative 4 minus the square root of 3. And when we simplify that, it'll be negative 4 minus the square root of 3 over 13. We can't simplify this anymore, so that's simplified as far as it can, and there are no more radicals in the denominator, so that is our simplified form. Let's try another one. Let's simplify 3 over 2 times the square root of 3 times the square root of 2. So we start by multiplying the conjugate of the denominator to the top and bottom. That'll be 2 times the square root of 3 minus the square root of 2 over 2 times the square root of 3 minus the square root of 2. Okay, the top we can multiply through and we'll get 6 times the square root of 3 minus 3 times the square root of 2, right? On the bottom, we know we can square this and we can square this, and the middle ones are going to cancel each other. So we'll have 2 times the square root of 3 times 2 times the square root of 3, which will be 4 times 3, right? Which is 12, minus the square root of 2 times the square root of 2, which is 2. Okay, so this is going to be 6 times the square root of 3. We can't pull any prime numbers or any more squares out of 3. Minus 3 times the square root of 2, that's also as simplified as it gets, over 10. So we no longer have radicals in the base, or in the denominator, so that's as far as we can go with that one. And that's it for that lesson. Do the practice problems and let me know if you have any questions. Thank you.